All right, so for in the first page, you had to graph your functions, find the zeros between them, as well as the relative mins and maxes. I didn't have my graphic calculator, so for some of them, the zeros I just put between. But again, if you had the exact zero because you did the second trace zero, that's totally fine. Okay, number 2. Or and then 5 and 6. Okay, and then if you flip it over, in section 6.5, we talked about factoring. And then let's check the back. So for 21, 22, 23, and 24, you were rearranging the terms to be in quadratic form, and then you were factoring them, and then solving for your values. All right, any questions, comments, concerns, anything on the 6.4 or 6.5 review that, is something maybe you struggled with, didn't understand, or needed to get a further explanation of? Do we feel a lot better about like the calculators? Do we feel better about factoring, polynomials, etc.? Yeah? All right, then we are going to move on to the next. You can go ahead and take out that new packet I gave you and do the warm-up at the top of the page. And I'll transition to our new slide. So if you're dividing by x minus 3, then you want to take the opposite of that, so that's a positive 3. It goes in your box corner there. And then you're going to take the coefficients of the terms, so negative 3, positive 5, and 4. We always bring down the first term, multiply, add, bring down, and multiply, and then add. So we get a negative 8. So the remainder of negative 8 tells me that x minus 3 is not a factor of the original problem. It is the remainder. So we know that x minus 3 is not a factor. So then it says compare the remainder of negative 8 to f of 3. So what we're going to do is take the number 3 and plug it into that original function. So you have negative 27 plus 19. So negative 27 plus 19 is negative 8. So if you have an answer that you get in synthetic, it is the same answer you get when you do the remainder theorem. So that leads us into today, which is the idea that we can do synthetic to find the value of a problem, or we can plug the number in to find the value of the problem. And we're going to talk about when it's more convenient to do which. So the remainder theorem essentially says if a polynomial p of x is divided by x minus r, that remainder is the same as the solution to when you plug in r to p. That remainder is the same as when you plug the solution in to r for p. Synthetic substitution is different from synthetic division in that we are using it to apply the remainder theorem by using synthetic division to evaluate a function. So synthetic substitution is a way of evaluating our functions. Everybody okay with the definitions? We good? So in example number 1, we're going to use synthetic substitution to find the value for 3 given that equation. So if you want to find f of 3, it's just like our previous warm-up problem, where we're going to take the 3, put it in our box, write out the coefficients, and perform synthetic. So again, this is an easy way to try to find the value of the function without having to plug in. It's nice when your numbers are big. It also makes it easier sometimes. So like for example, 3 cubed is 27. 27 times 3 would have gotten you 81. And then you had to subtract from 81 6 times 9, which was then going to give you 27. And then you had to add back to it 3, and then add to it 11. So plugging in 3 for the x just made your numbers a lot larger. I was talking about 87 or 81, 54, 27, and adding all of those and subtracting them together. Where here you are adding relatively small numbers and adding them together. So f of 3 is 41. That's what synthetic substitution tells you. It also tells me that x minus 3 is not a factor of this problem because my remainder was not 0. Why do we use it? Well, we use it because synthetic substitution can be way simpler for complicated problems. So here we have s of x equals 0.02 x of fourth minus 0.52 x cubed plus 4.03 x squared plus 0.09 x plus 77.54, where x is the number of years since 1993, and S of x is the number of students in thousands. You can find this function to estimate the number of U.S. students studying abroad in 2015 by evaluating the function for x equals 22, or using synthetic substitution. So if we want to know how many college students will study abroad in 2015, we can now use synthetic substitution for 22 in our corner box. Write down our coefficients. So I knew a 0.02. Well, 0.02 is really the same as a fraction as 2 over 100. So you could rewrite 0.02 as a fraction, and then you can multiply it by 22. So 2 times 22 is 44. So that's like 44 over 100, or 0.44. So now you can add these two terms together. So negative 0.52 plus 0.44 is really like adding negative 52 and 44, where the 52 is negative. So you get 0.08, and it's negative because the 0.52 is negative. And again, negative 0.08 is like 8 over 100 times 22. So you can just keep your decimals going by taking 22 times 8. And that is negative 1.76. Add those numbers together. So 4 and 1 gives you 3, but then you have your 7, 6, you have to carry it, so we'll make that a 13. Then that becomes the 9, and then the 3. So 13 minus 6 is 7, 9 minus 7 is 2, and 3 minus 1 is 2. So you get 2.27. Now you have to multiply that by 22, and again, that is a little less nice. So 2.27 could also be thought of as 227 over 100 times 22. And again, you could simplify your 22 and 100. Both would divide by 2, so you could get 11 and 50. So I kept it as 100 in case some of you did try to change it, so that all I had to do was move my decimals later. So I would just go over to the side if I didn't have a calculator and write out 227 times 22 the old school way. So 2 times 7 is 4. 2 times 2 is 4. Carry your 1. 2 times 2 is 4. Put in your 0. 4. Carry your 1. 4, 5, 4. Add them up. And you get 4994. But remember, we're dividing that by 100. So it's really 49.94. And then we're adding 0.09 to that. So you get 50.03. And one last time. So for the last one, you get 1166. And then adding them together, 6 and 4 is 0, carry your 1. So 6 and 5 is 11, and then you carry your, turns to a 12. So carry your 1. You get 8. If I won't write 7, 1, 1. So again, this would be a non-calculator SAT question. So I think it's definitely easier to take and do synthetic than try to take 22 to the 4th power. It's much easier for me to multiply 50 by 22 than 22 by 22 by 22 by 22. Agree? So again, the half of your SAT is non-calculator, so as you guys are preparing to take them, that's something that you're thinking about, and that's where synthetic substitution comes into play. Okay, so for example 3, we just want to find 3 values of that function, and we're going to use synthetic for each of them. So you're going to plug in your 3, 2, -3, -17, and 30. We always bring down the first, multiply, add, multiply, add. The hardest part, I think, of synthetic substitution is making sure you don't use your negatives. So like -17 and +9 is going to give you -8. And then you get -24. So you get 6. So what that means is f of 3 is equal to 6. And then to find the next value, your top coefficients stay the same. What you change is the number that goes in the box. So now if I wanted to find 10, keep your coefficients. You always bring down the first, and then you multiply and add. So you guys have been multiplying and adding since 3rd grade. So 10 times 2 is 20. 20 minus 3 is 17. 10 times 17 is 170. 170 minus 17 is 153. 153 times 10 just adds a 0 to that number. So it becomes 1,530. And then you get 1,560. Okay, let's look at -3. So when I do synthetic substitution for -3, I get a remainder of 0. If I get a remainder of 0, that means x equals -3 is a root of my function. That also means it's a solution. That also means x plus 3 is a factor. So on Monday, we're going to retake these synthetic ideas and we're going to factor complicated polynomials using synthetic substitution. So that's a preview of where we are going for Monday. One last example. We're going to plug in 2. Okay, so once again we get 0. So what that means is that f of -3 is 0, f of 2 is 0, so I have found 2, of 3 roots for that function. So again, it's a cubic. Cubics will have 3 real zeros or 1 real zero. They can never have 2 reals and 1 imaginary. So as we factor polynomials, we're going to go back to reals and imaginaries like quadratics. We're going to talk about how they come in pairs, and we're going to work through finding our factors. So that's where we are going on Monday. So for now, you guys are going to really work on synthetic. You're going to work on working through this and being able to find those zeros. So your homework is in that packet. You are doing that very next page, front and back. And then, like I said, on Monday, we're going to pick up with the second part of the remainder and factor theorem. And now we're going to use that evaluation to find the zeros and the factors.